I'm presenting this to you with my colleague Johann Füchsl. My name is Werner Schmid, and we are the founders of Red Lever Solution based in Vienna, and we are offering operations as a service to our clients. Yeah, today we want to give you an introduction into two tools that HashiCorp offers. The one is Terraform and the other one is Consul. We want to give you an introduction what Terraform is doing, what we expect it to help us, what the most important Terraform commands are, and then want to spin up more or less a default AWS EC2 setup and high availability setup with a Consul cluster and a web app in it, and want to perform all this in a demo where we show how Terraform can help us with these steps. Then Johann will give us an introduction in Consul and what a Consul cluster is and how it can perform service discovery, and also will show how Docker and Consul can be integrated, and show this in a demonstration of the setup we previously spinned up with Terraform, how the service discovery of Consul can automatically alter configuration files of the load balancers. Yeah, what is Terraform? Terraform is a tool that helps to build, change, and version infrastructure across different cloud providers like AWS, Microsoft Azure, Google Cloud, or also local resources like Docker or other resources like simple DNS. All those resources can be managed with simple configuration files, and this includes normal instances, network setup, DNS settings, and so on. This is more or less performed via simple configuration files where all your infrastructure can be managed, can be versioned, and can be shared. Terraform also stores the dependencies between your infrastructure so that everything which is needed for your instances, the networks, the security groups, for example, on AWS, are created previously to the instances, and creates some called resource graphs where you can see all these dependencies. What you also can do is, if you want to change something in your configuration, you can change this with Terraform. You just call the commando and it says what instances or resources it wants to destroy, modify, or create. Yeah, what are the most important commandos of Terraform? I think the most important two commands are plan and apply. With plan, more or less, you see what resources Terraform wants to provision on which cloud provider. And with Terraform apply, you can then start this provisioning and really provision those instances or those resources to the cloud. Then what's also important is Terraform destroy and Terraform show. I think it's quite obvious what those two commands are doing. Destroy destroys the whole infrastructure you previously provisioned, and with show you can show details of your infrastructure like IPs of your instances and other more or less all settings your infrastructure has. Yeah, we will now show you how we configure and spin up a default high availability setup on AWS, which is just one provider which can be used by Terraform. I think one of its strengths is that you can combine multiple providers like AWS, the Azure Cloud, or other providers in one configuration. Yeah, what we are doing is we are spinning up more or less a public and a private subnet with security groups to configure access to all our instances. But perhaps what we are generally doing, we want to launch a high availability setup for a web application, which is more or less based on a load balancer in front, and the web application behind it. And the load balancer will be automatically configured via the service discovery that Consul is offering. Yes, this setup looks more or less like this. We are provisioned that in Ireland on AWS, where we have 3 availability zones. In each availability zone, we will have a public subnet, a private subnet. We call it private static because in this subnet we host all instances which has a static private IP, and a private subnet where we host all instances which has not to be accessible via the internet. Now we see all the instances we will provision in those subnets. Let's start on top, where we have the net address translation instances to provide internet access for all our instances in the private subnets. We also see one bastion host. Via that host, we are able to access all instances in all subnets. And we see the 3 Consul server, Consul 1, 2, 3 in the private static subnets. This is the Consul cluster. Johann will explain afterwards in detail to change the configuration of the load balancers and to discover the web applications also located in the private subnets. Okay. I will show you now some Terraform configuration files and will spin up this setup. Yes, we have here a directory where all our Terraform configuration files are located. The files that end in TF are the ones which are interesting for Terraform, and we will look into one of that files. For example, the bastion host. And we see it's a quite simple configuration file where we define our instance type, we define our Amazon machine image, we define the subnet this instance should be launched in. Then we define some cloud config files to provision the applications which should run on that server. Then we configure the security groups to access the instance and to enable access between all those instances I showed previously. We can also manage our SSH keys, and we also assign an instance profile to that machine and also to the other machines to be able to access our application data provided on S3 in a secure way so that it is not publicly accessible. With Terraform plan, we now get a quite detailed plan what Terraform wants to do if we perform Terraform apply. And we see here it wants to provide a lot of resources, an auto-scaling group for the load balancer, an auto-scaling group for the web application, elastic IPs for the net address translation gateways, an elastic load balancer in front of the auto-scaling group with the load balancer in it, and so on. So you can imagine that to configure all this via the Amazon console is possible, but quite error-prone, and it's much easier to provide this whole setup via a configuration file where you have a clear mirror of the whole infrastructure you have running there. So we now can have a look into the EC2 management console to see that there is really nothing running. So no instances are there, and we now are going to launch all those defined instances here. I hope this works now, because internet was quite slow before. What's important to mention here is that because Terraform knows the dependencies between the resources, it launches some instances after the others and can perform tasks in parallel which have no dependency. Yeah, I think in the meantime, I think this will take around 2 or 3 minutes. I think in the meantime, Johann can give you an introduction to Consul.
Okay, hello everybody. It's really nice to see so much of you have made it here. The second part of the talk, which I will present, will be on the thing that is actually running on the infrastructure that Werner just spinned up, or is in the progress of spinning up, and talk about Consul, how we do service discovery, and so on. So let's dive right into it. Consul was created by the awesome people of HashiCorp, like Terraform, and it's a technology which you can do service discovery and configuration management with. It's designed to be distributed, highly available, and multi-data center where out of the box. So some of the features I will present in a bit more detail. Service discovery. Service discovery basically means you have a central catalog of component services that offer something that something else needs. Like, for example, in web app, a database, maybe a cache, maybe something else. With Consul, you can even register some third-party services like an external API that you happen to be using. And with that in place, you can dynamically create and manage your services. You can discover them. You can deregister them if you decommission some part of your infrastructure, etc. And that enables you to build elastic systems. That means that each component knows what it has to have access to, what its dependencies are, And via the service discovery mechanism, it can get the exact locations and all the stuff it needs to connect to these services it needs. And so you are very dynamic. You can scale each service, each component up and down based on your load pattern, based on whatever you think is necessary. So naturally, it's really good to have if you do microservices. How to access all this stuff, this information that service discovery gives you. It has interfaces for DNS, which is a little bit limited due to the nature of DNS. And you have an HTTP interface, which gives you all the power and all the possibilities that Consul offers you. So you can query your services based on the data center there are, based on the health state, etc. And you get much more information out of Consul via the HTTP interface. And service discovery is nice, but it really doesn't help you if some of your services are down, you don't know about it, and you send requests, and you get errors and errors. So we have something called health checking, which lets you define health checks for each individual service, for each instance of each service. And if one service has any problems, it goes down, it's decommissioned, the health checking says, okay, this is unhealthy, we cannot route any requests to it. So this increases the uptime, the availability of your service, and helps you. You can also plug it into monitoring, automatic alerting. You can do basically whatever you want with it, however you want to react to things like that. Maybe it's really natural that many services go down. Maybe you want to react somehow to it. So it's basically up to you. On the lower level, Consul is just a distributed key value store. That means you can assign a key value pair to it. Consul makes sure that it's consistently available on the whole cluster. And that lets you do a few cool things. You can do dynamic configuration management. You can do feature flagging. You can coordinate some kind of actions that you want to do over your whole infrastructure. You can trigger some events, whatever. And yes, it's multi-data center where you can spin up a cluster in data center A, in data center B, another one. They can communicate with each other. The service discovery mechanism allows you to query services only in data center B. So you don't have to do that much extra to get this out of it. And to use all of this Consul awesomeness, you have to have some kind of tooling, right? You have to be able to access it, and it should be fairly comfortable. You don't want to write a whole lot of stuff to be able to use it. In our demo, we will use two such tools. The first one is Registrator. It's a Docker image or a Docker container. And what it does, it links into the event stream of the Docker engine it runs on. And it listens to containers coming up and containers being stopped. Each time some of these events happen, it checks if this particular container offers a service, and you can configure that in the container or the Docker image via environment variables. It goes ahead and says, okay, here Consul, you have another service. Or if the container is stopped, it deregisters it in Consul. So if you have a Dockerized environment already, this is perfect for you because you just commission this registrator container, and your services are just there and it works. And on the other side, you want to do something with those information in the Consul. You want to use them to maybe build some configuration files. You want to make sure those are up to date. you want to react on values changing in Consul. And for that, we use Consul template, another tool. It is developed by HashiCorp too. And what it does is basically template rendering. So you have a template file, which is maybe a configuration file for, let's say, HA proxy. And what it does, it runs in the background and it listens to changes in Consul. And whenever something happens that's interesting to it, it re-renders the configuration file and executes something that maybe restarts the process so it uses this new configuration, which, by the way, for HA proxy is really tricky to do, right? But it's possible. And yeah, there are a whole lot of other tools, and I suggest you can look at the Consul homepage here. They are listed there, very thorough. You have a lot of SDKs for Java, Node, Go, whatever. I think if you look for something, you will find it there. And if it's not there, it has an HTTP API. Feel free to write it. Now let's converge back to our demo that hopefully is spinning up or is already spun up. And I will now talk about the setup of Consul that we are using. A Consul cluster consists of server nodes and of client nodes. The server nodes are responsible to store all the data, to coordinate all the requests, to make sure it's consistent and available everywhere. So naturally, those servers are quite critical. And naturally, we want them to be up all the time. Consul provides us with a mechanism for this, where basically a majority of these Consul servers need to be available. They need to form a quorum. And so when you have, for example, 3 servers, one server can go down, you have 2 servers left, 2 is a majority, and they function. So we just put 3 Consul servers across different availability zones, and our goal, and we can tolerate one node failing, one whole availability zone failing, and it's okay. And then we have the clients that just connect to the servers. So this is a little visualization of the whole situation, with the servers in the middle, and we have the clients that just connect to one of the servers. Okay, now our demo is really, really simple. We have one service, it's a web app, and it's written in Node.js. And what it does, it basically lists itself. So it goes to Consul, says, hey, I'm a web app. I want a list of all the web apps that you have, and send it to me. It then marks itself in the list of web apps, presents us in the browser this list, and itself highlighted so we know where the request came from. Real simple, and we spin up a few of those web apps, I think 5 by default. And in front, we have a load balancer, HA proxy, which just round robins requests to all of these instances. So yeah, that's the situation. We have the web app which runs in a Docker container conveniently, so we just deploy the registrator container with it and are golden. This will register each web app in Consul, and then Consul template will take care of the rest, configuring HA proxy and keeping it up to date. So now we should try to see if it worked. This seems quite okay. So we should be able to. So this is a Terraform output. It outputs some of the interesting parameters that we may be using. For example, the elastic load balancer DNS name, which we then use to connect to our demo. So let's copy that. And right. Yeah, we now have to show the registered members. And, well, it looks good. I think the green one is the one where the request came from. And maybe that's, yeah. So it round robins through all of the instances, works like it should. It's not that interesting, but I think you get the picture what you can do with it. And interestingly, Consul has a web UI. I want to show you that too, because it's really informative if you want to have an overview of what's running where and what nodes you have, etc. Okay, so it shows us a few things. Here it lists all the services it has. Right now we have 2 services. Consul, obviously it registers itself. And we can see on what nodes, so what servers these 3 Consul servers are running. As Werner mentioned, they are in the static private IP space. So yeah, it's easier to bootstrap the whole thing because you know the IPs when you start. And we have the web app services, which are running on 5 different nodes listed here. And you can click on any one node and get some additional information if it loads. Yeah. So this is the nodes view. You see the nodes that we have commissioned here. So load balancer, some Consul and some web app nodes. We see a basic health check, and it means everything is green, everything is good. Okay, wow, we rushed through it quite a bit. Can we see? Yeah, and so it really spun up of all of that. Okay, I think that's it for the practical part. If you have any questions, I and Werner will be really happy to answer them. I will put the slides and the demo on GitHub, and you know where you can find us. So thank you very much. Are there any questions? Please.
Is it a good practice or is it possible to integrate this monitoring platform with Kubernetes, or it's not good to do it?
So you mean Consul with Kubernetes? I think it's possible, yes. I'm not really up to date what Kubernetes is already doing by itself. I think it has some kind of service discovery in place, but if you really want, of course, you can do it. You can put all of your Consul stuff cluster, so servers and clients into Docker containers. You can distribute them on top of Kubernetes. You could distribute it parallel to it and just connect to it. I mean, I don't see any reason why you couldn't do it. So yeah, of course you can. Anyone else? Please.
Maybe a little bit off topic, but the Terraform state file, what's the strategy for handling that since the state is stored locally?
Yeah, throwing your arms in the air and hoping it will be better. No, I think you can upload it to Atlas, which is a central service that HashiCorp offers, and it should work. Basically, what you should never do, or what we really strongly advise against it, is check it into JIT, because someone found out that it could happen that there are some private credentials stored in it, so it's a bit of a risk to do it.
I think it's very important that you care about your Terraform state files, because there can be very critical credentials stored in them, like root passwords for databases on AWS RDS or something like that. So I would suggest so we do it that we encrypt the file and delete the blank Terraform state file, because we don't want to have it unencrypted on our file system.
Can I just wrap it up and then you're next? On JIT.
Not this one. You could pretty much also store them in another HashiCorp product.
Word, yes.
Yes, exactly. On GitHub, there is a discussion going on exactly about this. And I think a few months ago, I suggested to maybe write a Vault integration to handle this, because it would be perfect for it. I think no one has picked it up yet, and I didn't have the time to do it myself. But there is a discussion at least, and I'm really excited to see how it works out, because right now the situation is not that optimal. Okay. Yes?
You mentioned the templates for organizing the health checks. Does that need to be pushed out to every node, or is it centralized? Or how do you configure those on the fly?
I think they are scheduled to be run by a server, so they should be on a server, or it should be possible to run it on an agent. So I think both ways are possible. I think there is nothing wrong with having them locally where the service is running and executing them from there, because when the node goes down, you will get another health check error from the underlying gossip protocol that they are using, which has this default health check if the node is alive and communicating in the gossip, if it's alive and participating in the gossip. Mm-hmm.
In your experience, would you have one Consul cluster for the entire organization, or would you have one product?
Really depends. Really depends. I would naturally tend to have one for every product if I'm quite sure that no interdependencies arise from thin air. So yeah, whatever fits best, I guess. Okay, maybe some questions from this side? No? Come on, guys, don't be shy. Question?
Technical question. Do you have any experience with problems on Amazon EC2 services because of UDP filtering? They have no UDP and Consul works on UDP.
With UDP? I never ran into something like that, so I can't say we have that much experience with using UDP on Amazon. Sorry. Okay. You would have to you would have to adapt the provisioning of the nodes, which we did very simple with just copying from S3 and then executing a script. So you would have to adapt the Terraform files to the new resources for Azure. You would have to adapt the provisioning scripts, and yeah, I think that is it. Software just runs on it. Okay? Another one.
You have, for example, you created your resources manually, is it possible to create from this existing stuff?
I think it is possible to more or less manually write the Terraform state files so that it maps a resource you launched on AWS manually to your Terraform-defined infrastructure. But this is really then manual hacking the Terraform state file. But I think as the Terraform state file is quite straightforward, it is possible. But I've never done it. But I thought about it, and I think it would be possible. It is possible to manage scaling up and down with Terraform because the desired quantity of nodes in an auto-scaling group or the number of instances is just one variable in the Terraform configuration files. But I think it's not built for it, so I would suggest to do that with other tools.
But it's possible, of course. Okay?
No. I mean, it's possible. We built this demo with two auto-scaling groups, one for the load balancer and one for the web apps. The reason why we did it for the load balancer is if the instance is terminated or is corrupt, the auto-scaling group mechanism automatically provides a new one. For the web app, it is obvious we wanted to have an auto-scaling group to just scale the app. But back to your question. It is not reflected, so the current state of the auto-scaling group is not reflected in the Terraform state file. Okay. Thank you very much for listening.
Thank you very much for coming.